In number system, one important thing which all the students should learn is classification of numbers. Because until and unless I'm clear with the type of a number, I'll not be able to understand the mathematics clearly. So for the better understanding of numbers, you should first understand classification of numbers. So before I start, I want to know from your end, if I ask you to think about different type of numbers, you will say, sir, I'm aware about real numbers. Then there are natural numbers, integers, fractions, rational, irrational, whatnot. So if I ask you to make one single category, a category where all the numbers will fall under 2. So can you give me the name of that category? हमारे पास डिफरेंट टाइप के नंबर्स हैं. मैं ये बोल रहा हूँ कि अगर मैं इन सब नंबर्स की एक सिंगल कैटेगरी बनाना चाहता हूँ तो उस कैटेगरी का नाम क्या होगा? ये सारे के सारे नंबर्स कहाँ से ओरिजिनेट करें? तो यू वुड से सर ऑल द नंबर्स ओरिजिनेट फ्रॉम कॉम्प्लेक्स नंबर. Whatever numbers exist in this world, they all start from complex number. It means complex number is the root node, right? So I'm going to begin from complex number. Now somebody asks you, what is a complex number? You would say, sir, a complex number is a number which can be expressed in this form, a plus ib, where a is the real part and ib represents the imaginary part, right? In this expression, if I plug in the value of a0, listen to me carefully. अगर मैं इस expression में a का value 0 plug in करूं, I'll be left with ib. What is IB? IB is the imaginary part. It means whatever numbers I'll get then are going to be imaginary in nature. In the same expression, if I plug in the value of B0, in first case, I have plugged in value of A0. But now what I'm saying, let's plug in value of B0. Then whatever numbers you'd be left with are all real. And therefore, the numbers would be called as real numbers. So can I say complex numbers can further be divided in two parts? One category of numbers would be called as real number and another category of numbers would be called as imaginary numbers. So what we have understood that complex numbers can be divided in two parts, real number and imaginary numbers. So guys, as far as our component is concerned, quantitative aptitude, you will not find even a single question जहाँ पे वो तुमको imaginary number देंगे. So there is no point of discussing imaginary number further. We'll just focus on real numbers now. So if somebody asks you what are real numbers, we'll simply say anything which can be expressed in a number line. Any number which I can express in number line is called as real number. Nothing could be simpler than this, right? So if we talk about real numbers further, real numbers can be further divided in two categories, rational and irrational number. So if I ask you what are rational number, you would say, sir, a rational number is a number which can be written in the form of p by q. Then what is irrational? Which I cannot write in the form of p by q. Simple definition. So if I pick some examples, so if I ask you about 7 by 4, is 7 by 4 a rational number? You would say definitely, because it is written in the form of p by q. Then what about 5? Is 5 a rational number? Now here you have to be a little careful. By looking at the face value of the number, you will not decide whether a number is rational or not. As per the definition of rational number, please try to recall what I have told you about rational number. A number which can be written in the form of p by q. So it may happen the number is not presented to you in the form of p by q. And therefore, you need to check क्या हम उस नंबर को p by q के फॉर्म में लिख सकते हैं? क्या 5 को p by q के फॉर्म में नहीं लिखा जा सकता? You would say, why not, sir? I'll write 1 in denominator. And now the same number can be seen in the form of p by q. So is it rational or not? You would say, yes, sir, it's rational. The definition of rational number says a number which can be written in the form of p by q, right? So before commenting whether a number is rational or irrational, you have to try writing the number in the form of p by q. So even after trying, if you are not able to write a number in form of p by q, it means it is not rational. Simple definition. Now likewise, if I ask you about 0.5, Is 0.5 a rational or irrational number? You will say, sir, although uh, at present the number is not written in the form of p by q, but this can be written. I remove the decimal and then I'll get 10 in denominator. Since I'm able to write it in the form of p by q, therefore ये number भी क्या है? Rational number है. So the definition of rational, try to recall a number which can be written in the form of p by q. I hope all these examples are clear. So let us talk about irrational number. You already know an irrational number is a number which I cannot write in the form of p by q even if I try. So some examples of irrational number are any non-perfect square number written under square root is an irrational number. So 1, I have skipped 1. Why? Because 1 is a perfect square number. 2, 3. Again, I'll skip 4 because square root of 4 is 2 and 2 is a rational number. So any non-perfect square number, so next number would be 5, then 6, then 7, then 8. I'll skip 9 because 9 is a perfect square number. Then I'll move to 10. So like this, I can write down different examples of irrational number. Another famous example of irrational number is pi. Pi is an irrational number. But now I would like to challenge your understanding of irrational numbers. If you try to recall the definition of irrational number, an irrational number cannot be written in the form of p by q. Even if I try, I cannot write it. But guys, we all know that one value of pi is 22 by 7. So if I ask you, will you be able to write pi in the form of p by q? The answer is yes. So if I can write it in the form of p by q, how could I say it's an irrational number? Think about it. I hope my question is clear. अगर पाई एक्चुअल में इरेशनल नंबर है तो ये p by q के फॉर्म में नहीं लिखा जा सकता, बट मैंने तुमको लिख के दिखा दिया. तो अब मेरा क्वेश्चन तुमसे ये है कि पाई इरेशनल क्यों है even though I am able to write it in the form of p by q. So let me give you the answer now, guys. Because 22 by 7 is not the real value of pi. Now to understand this, you have to understand some things about decimal numbers. So I'm just moving a little down to discuss something crucial about decimal numbers. So if you think about decimal numbers can be divided in three broad categories. One is called as terminating decimal. The first category is terminating decimal numbers. The second category is non-terminating but repeating decimal numbers. And the last category is non-terminating and non-repeating. So to understand why pi is an example of irrational number, you have to understand decimal numbers first. So the first category number are called as terminating decimal. So what are terminating decimal? Let's understand through example. So if I write down a number, let's say 0.5 or 0.80 or for that matter 0.2, all these numbers are terminating decimal number. After decimal, you would realize that, okay, it is terminating at some digit, isn't it? And all these numbers can be written in the form of p by q. You can see yourself. You remove the decimal and you can write down these numbers in the form of p by q. So can I say all terminating decimal numbers are actually rational in nature? Why not, sir? I hope terminating decimal numbers are clear. Let me come to non-terminating but repeating decimal numbers. Let's again understand it through examples. So if I write one example 0.833 and it will repeat until infinity. Let me write another important example. Let me write another example 0.33 or 1.6666 and it will repeat until infinity. So all these kind of decimal numbers which are not terminating, can you see that they are going until infinity? So they are not terminating. But there is an interesting thing which you should note down. One of the digits or more than one digit is repeating. Now what I can do here is, if you see 0.83333, since 3 is being repeated infinite number of times, so what I can do, I can just put a bar over the repeated digit. Likewise, if I do the same thing for 0.333, you would say, sir, since 3 is being repeated multiple times, infinite number of times, so I'll put a bar over this. Likewise, in the third number, I can put bar over 6. Now, whatever numbers are from this category, non-terminating but repeating, all these numbers can be represented in P by Q form. Try to understand. I'll not discuss how to write such numbers in form of P by Q, but I want you to realize that all the numbers which are non-terminating but repeating can be expressed in the form of P by Q. There is a way, and therefore these numbers are also rational in nature. Now here comes the last type of decimal number called as non-terminating and non-repeating decimal numbers. So to understand what type of decimal numbers are called as non-terminating and non-repeating, let me write an example for you. So if I write a number 3.14, I'm writing any random number, not writing any specific value. So if you see this decimal number, what would you realize? That it is not terminating as well as it is not repeating anywhere. None of the digits are repeating. And because of this, since none of the digits are repeating, it's non-terminating. There is no problem in being non-terminating. But at the same time, none of the digits are repeating. And because of this, I cannot write such numbers in the form of P by Q. See, to write a non-terminating number in the form of P by Q, I have to put a bar over a digit. And bar can only be put if a digit is being repeated. But since none of the digits is repeating, so can I write down this number using the bar convention? The answer is no. And if I cannot write this number in the form of P by Q, it means all non-terminating decimal numbers are example of irrational number. I'm repeating, all non-terminating and non-repeating decimal numbers are example of irrational number. So try to understand. Let me go back. So when you say that the value of pi is 22 by 7, before citing this reason, you need to understand, if you search for value of pi, if you Google search, you would realize कि जो pi का value है, it's a non-terminating as well as non-repeating decimal value. अभी तक pi का value हम compute कर ही नहीं पाए हैं, और साथ ही साथ ये एक ऐसा डेसिमल नंबर है जो नॉन टर्मिनेटिंग है और नॉन रिपीटिंग भी है, और ऐसे नंबर्स को p बाई क्यू के फॉर्म में हम लिख ही नहीं सकते. तो अगर पाई का वैल्यू p बाई क्यू के फॉर्म में लिखा ही नहीं जा सकता, तो फिर पाई क्या हुआ? यू वुड से पाई मस्ट बी एन इररेशनल नंबर. then what is this value? 22 by 7. So you need to realize, guys, 22 by 7 is the approximate value of pi. This is not the real value of pi. This value is actually given by mathematicians to make our calculation easy. That's all. Now, if you're thinking, why specifically 22 by 7? Because when you solve 22 by 7, see, 7, 3, 21, you get 1 here. You'll put a decimal, you'll get 0. So 717. And then again you'll put a 0 here. Then 7428. So what would you realize? Until 2 digits after decimal, the value is matching. The value is matching with pi. And therefore, mathematicians has given this approximate value for pi. This is not the real value of pi. Try to understand. The value of pi is a non-terminating and non-repeating decimal number. And such numbers cannot be expressed in the form of p by q. So this 22 by 7 can never be the value of pi. Understood? It is just an approximate value, and therefore I cannot cite this as my reason to say it a rational number. I hope now you have understood why pi is an example of irrational number. Right? So this is all in irrational numbers. Now we'll continue a discussion on rational numbers. But since I don't have space here, so let me do one thing. Let me continue a discussion from here. Okay. So I'm again will continue the tree from rational numbers. So try to recall what were rational numbers. Rational numbers is something which can be written in the form of P by Q. So what I want you to understand, rational numbers can further be divided in two categories. The first category is called as fractions, and the second category is called as integer. So rational numbers can be divided in two parts, fraction and integers. So if somebody asks you what are fractions, you would simply say the fractions are also rational numbers. But here there is an important property which you need to check. Fraction भी rational number है. But the important thing which you need to check is the value of denominator should be greater than 1. So what is the definition of fraction? A fraction is a rational number whose denominator value should be greater than 1. Let me write some examples for you. So if I write 7 by 4 or 4 by 7, 1 by 2, 4 by 3. If you look at these examples, all these are rational numbers. But at the same time, if you focus on denominator, in each and every example, you realize that the denominator value is more than 1. And therefore, such type of rational numbers are called as fraction. Then what are integers? Integers are also rational number. The added property is here the value of denominator should be equals to 1. So the complete definition of integer would be an integer is a rational number where the denominator value should be equals to 1. Let me write some examples. This will make things easy for you to understand. So if I write 7 or 4 or 5, any integer, right? 8 minus 7. What would you realize that all these numbers are also rational. But the interesting thing to note down is the denominator value in each and every case is 1. A rational number where denominator value is 1 is called as integer. I hope the difference between fraction and integers are understood. Okay. Now we'll continue our discussion on integers because integers is very important for us. Now if I ask you, how many types of integers do we have? You will say, so there are 3 types of integers. There are 3 types of integer. First category, negative. Second category, neutral value. And third type of integer, positive integer. So we have negative integer, then we have a neutral integer, then we have positive integer. Try to recall, in number line, in between we show 0. So 0 is neither negative nor positive. To the left hand side of 0, we show negative integers. And to the right hand side, we show positive integers. Now here comes the important part. If I ask you to make a set of positive integers, what I want you to make a set of positive integers. You will say, sir, a set of positive integers will start from +1 and +2, +3, and it will keep on moving like this until plus infinity. So the same set of positive integers is also called as natural number, a very popular name. So somebody asks you, what are natural numbers? From now on, you won't say natural number are numbers which starts from +1. No. Natural numbers is a set of positive integers. And this itself represents, or this itself explains why natural numbers start from +1, because it's a set of positive integers. Likewise, if I ask you to make a set of non-negative integers, so you'd say, sir, since I have to make a set of non-negative integers, it means I have to exclude each and every negative integer. So this set will start from 0. I'll exclude negative. Apart from it, everything needs to be included. So this will start from 0 and then all positive integers. So +1, +2, +3. I'll keep on moving like this until plus infinity. The same set of non-negative integers is also called as whole number. Right? So somebody asks you, what is a whole number? You would say, sir, a whole number is a set of non-negative integers. And that is why whole numbers start from 0. So I think we shall end this lecture here, because otherwise it will be very lengthy for you to cover everything in one session. So this is all in this lecture. There are other things which we have to understand, but please try to understand that today what we have discussed classification of numbers on the basis of number system tree. So this tree-like structures is actually made on the basis of number system tree. The basis should be clear. So we started from complex numbers, then we come down to real and imaginary numbers, then real numbers is further divided into two parts, rational, irrational, and then we discussed some important key terms, natural number, whole numbers, right? In upcoming videos, I'll show you other ways of classifying numbers. So stay tuned. But for today, this is more than enough. I hope you have enjoyed this session. If yes, please like and subscribe. So this is all from my end. Thank you and have a nice day.